Hi everyone. So in this video, I am going to discuss my learnings which I am able to accomplish today. So let's move forward. So I am able to prepare notes of chapter 1 of Hugging Face tutorial. And specifically in this video, I'm going to discuss about transformers, what is the architecture of transformer and how they work. So let's focus on transformer. So basically, transformer is a modern way and it's kind of a model architecture which is used in LLMs and NLP to enhance their processing. And it's kind of a special mechanism which work on attention, and we usually call that attention is all we need in our natural language processing as large language modeling. So let's move forward discussing the architecture of transformers. So here is a well-defined uh, architecture of transformers. So basically, transformer are of three type, which have encoder only, example BERT, and which have decoder only transformers like GPT, and then we have encoder and decoder, which combines both things and help us to generate translation and summary of the text. So let's focus on the architecture itself. So this is the basic architecture of a transformer, like generic architecture we can say. By looking at first, it looks like difficult to understand, but to ease the understanding how a transformer works. So usually we have two things in transformers. We have encoder and then we have decoder. So we give some input to encoder and input process those input and generate some output, and that's become an input to decoder, and then decoder do its task and give us the desired result. That's how transformer work. So let's see what are all the things which transformer do for us in encoder and decoder part. So how it works, like we give some input to our encoder. We are discussing encoder now first. So we give our input to encoder, and then we generate a static embedding using this input embedding, and then we add a positional encoding here in this step, and then we able to generate the positional encoding of our input. And then going forward, we have three matrix here, not represented in the diagram by the name of V, K, and Q. And we use those metric using multi-head uh, self-attention, this, and then we add normalization. And going forward, then we have a neural network, which is called feed forwarding. And then at the end, again, we add normalization. So how all this works, let me represent it by an example. So let's suppose we have an input here dish, then we generated an input embedding and then added the positional embedding in it. Then we have in this multi attention head, we have multiple attention heads like attention head 1, 2, and up to n like this. And after that, we got an output which is enriched context embedded, contextual embedded output here. Then we add normalization. Now we can skip step for this one. So, like we give a positional encoding to multi-head attention, self-attention module, this thing. So what it does with our input, we have three matrix here with V, Q, K, and Q. Three matrix here. We have multiple attention heads here. Like we can have an attention head here. Then by using this attention head, we process our input and produce a contextual reached embedded uh, output from here. So it is enriched in contextual, like our model is able to understand the context of the input which we are used here. Then this input, or we can say this output, which is enriched in contextual embedding, is passed to the feed forwarding network. So feed forwarding is basically a neural network, and that input which we pass to it, that will go through a fully connected neural network layer in this, and then we will get an output which is more uh, like enriched in contextual embedded, and we able our model will be able to understand it in a better way, and the output which is generated by this feed forwarding network, neural network, is being added with the output which we are generated from this multi-head self-attention, and by addition of these two outputs we get the final output which is enriched in conceptual embedding, and which is suitable for uh, the decoder also. So let's understand in detail like what is a feed forwarding network. So the feed forwarding network enriches each token embedding by applying non-linear transformation inside independently, enabling the model to capture complex patterns and trigger order features beyond contextual relationship. So this helps us our like model to understand and capture the complex pattern which is in our input. And let's discuss this normalization layer, which we leave for later to discuss. So basically, what a normalization layer do? So normalization layers ensure stability learning, improving the gradient flow. Like it will stabilize our output and make it more stable to use. And usually we have NX layers here, so we can see you this is a whole NX, and we have two NX layer here like this, and each we can have multiple layers like this in a single here. So NX layer can be different with different kind of module. The module which we are using, like here we have BERT. So BERT is also of two types. If we are using BERT basic, so we will have 12 layers like this, NX 12 NX layer like this in our encoder. And if we are using BERT large, then we will have 24 layers. And in case of GPT, it will be different, or like in decoder. So now what we did, we gave an input and we able to generate a contextually uh, enriched output from here. And now this output will become input for our decoder. So output of encoder is contextually embedded and or context reached, which we give as input to decoder. Then what decoder will do, what is the task of decoder here? It will predict the next word if we are generating text. It will translate the next word if we are working on translation. So let's suppose we provided this, everything remains same, like we uh, em- output embedding here, static embedding here, then we add positional embedding, then similar kind of thing. It will have attention heads, multiple attention heads. So the main difference lies here. Everything remains same other than this. So here what we are doing, here V and K, these two things are coming from here. So it becomes, it is here multi-head cross attention. So why it is cross attention? Because two things, two matrix like V and K are coming from the encoder, and the query part. This is the query part which is coming from the masked multi-head self attention from decoder itself. That's why it is called cross attention, and the rest of things remains same in the decoder as well. And then finally we were able to accomplish the task which we are doing here. So that's how the transformers work, and that's how the things is done using transformers. And you can see that I able to complete all the notes and also able to complete the quiz. Let me see if I can show you that. Where is my hugging face? So not with me now. So yeah, that's all I am able to do today. Yeah, thank you so much.